All right. Well, hopefully lunch was good and had fun trying to figure out how to do the raffles and seeing who won. This afternoon, I'm going to kind of continue this. We've been working on this morning. We worked on this communication layer, the SNP and Bluetooth. And then we'd like to kind of move on to the port scanning of an IoT device. I believe we can do that one as it currently is set up. Actually, let's take a look at this real quick, because I think we're going to set up the Raspberry Pi on the network, right? So if we're using Nmap and other things, that's going to be on the Kali Linux box. So then I'm thinking we're going to try to fire this up, and hopefully it's not just Oracle VirtualBox giving us a problem, and we're hoping that it's the DHCP. But I do think I'm going to have to drop this onto the other network adapter, which actually may cause a problem. So let me see if that does cause issues. All right. So here's my virtual machines, and I just on my Kali Linux box, I changed the network adapter to be my primary network adapter. So we're going to try this, see if it jumps. Because I was looking, the next lab, the follow-up to this one, this crafting packets, is also, it is a Raspberry Pi lab. We're going to actually, we do a bunch of stuff on the Raspberry, and we watch it with Wireshark and stuff like that. So these are both, Raspberry Pi labs where we're using it as to generate traffic for us. So I'm hoping that this does not cause us issues with my connection. If it does, right, sit tight. I'll be right back. Let's see what happens. So far, I still see everybody. Hopefully not. Oops. So then my next, am I still here? No, am I all on my own? Okay, good. So my next thing is I am on I think this is a statically assigned address. I need to make it a DHCP. Wonder why that's the only network settings I have. Crud. So I think because what I want to do is I want to have this, right? I want my Kali Linux on my regular network. I don't want it to be, and I don't want it to be statically set up, right? So this would be, I wonder if your cheat sheet has the right command. I know you can set the address like, you know, like that, like, but I don't do this enough to remember how do you set it as DHCP. All right. Do I
I
need
put it in the chat for you, Gary.
okay, do I need both of the commands or do I just need the second one?
Oh, you need to open up the interfaces file and then add those two.
Oh, you add those two items there. Okay,
Right, right.
cool. Wonder if I need to do sudo that. We'll try, see what happens, see if it gives us a problem. What happens when you, yeah, so right there. So we don't want, what I'm gonna do then, I'm just going to, oops, it's not what I want to happen. This is what I want to happen. And that. Fair enough. And it did right here. So that's what we wanted. So now I have my virtual box Kali Linux machine on my regular network, which is where my PL app and my regular Raspberry Pi are located. Okay, so the point of that was in this lab, these two things, your Kali Linux needs to be on the same network that your Raspberry Pi is on. So if you are working in the lab environment, you know, and you can just follow the instructions as they are, fire up the DHCP and do your thing. If you're not in a lab environment, you just got to do pretty much kind of what I just did is like, tell it which network adapter is actually connected to the live network and make sure that you reset the IP address to either a static address on that network or allow the machine to grab a DHCP address off the network. So from here, then I should be able to ping 172.17.69.135, which is the PL app. And I should be able to ping 171, which is the Raspberry Pi OS. All right. So just from a simple communication standpoint, these three machines can see each other. All right. So this is port scanning an IoT device, right? So the objectives, we got 4 parts here. Perform Nmap network discovery scans, compare an Nmap TCP default port scan and a full scan, perform an Nmap UDP scan, and then perform an Nmap OS and service footprinting. Okay, so awesome. We're going to play with Nmap. Okay, so they do point out Nmap's included in Kali. If you wanted to put Nmap on your regular Raspberry Pi, you could just simply go to the nmap.org and download it from there. Or I'm sure it's probably an apt-get that you can install, right? Or a pip or something along those lines. There's going to be some way for you to install that on any Linux machine. Right? So it doesn't have to be Kali to run Nmap. Okay, Raspberry Pi, and we're going to be connected to the, we got the Kali VM and network connection between those two. Okay, so that was the part that we were fixing just now, is this network connection between those two. We made sure that they're both on the same subnet. Okay, so the first one, part one, perform an Nmap network discovery scan. Okay, we're going to use Kali to perform a host discovery scan. Okay, this does have us walk through and set up, right? We're going to plug in get our topology set, right? So where the Kali Linux is on the same subnet. We've done an if config, right? So I know my address here. It's not there. So my address on my Kali box is 211. So I'm just going to do Kali. I'm just going to write these down. And I know 0.135 is my PL app Raspberry, and 0.171 is my Raspberry Pi OS. Awesome. Open the manual page or the man page for Nmap, right? So man Nmap to get the manual page. So then from here, refer to the manual page, complete the table below. There are many other resources available online, right? So it looks like they want, to have the students kind of look through options, right? So look through options, what's the name, what the notes related to that particular option, okay? For us, it's not something we're gonna do in this particular lab, but that's where we're gonna start. And I like that idea because we have them start to, first of all, get comfortable using manual pages. And then secondly, they start to learn more about the actual command and the utility versus simply just typing in the commands, which is what we're going to do. So we're not going to Nmap 203. You need to Nmap whatever so Nmap, right? And you need to Nmap whatever your subnet is, right? So my subnet is 172.17.69.0/24. That's mine, okay? You use whatever your subnet, whatever your personal subnet is, right? And you'll be able to get that from here and here. Just going to run Nmap here, okay? And we're going to see what it sees on this network. I'm afraid. Earlier, we were only looking at Bluetooth, and there was a ton of Bluetooth. Let's see what Nmap can find on my network. So the scans take a little while. And we're supposed to try to discover what IP address our Raspberry Pi is. We'll kind of see what the results are and see if we can find it. Right, so we got a ton of results here. So Nmap report, so there's a device at 172.17.69.69. FTP, SSH domain, HTTP, NetBIOS. This is my router. There's a device at 111. No idea. That's concerning. It's just the name, right? TCP is open and the service is called Abyss. The next one is there's a 128. So that's a Apple file server. Okay. So the device set up as Apple file server. There's a 130. Again, that has Abyss on. I wonder. Those may be the Rokus. Somebody had the same question. It's like, what is that? I'm looking up what it may be. So it's a web server. Interesting. All kinds of theories. Somebody says maybe it's an office jet, right? I don't know. That's interesting. So I also have 111 or 130 has a BIS running on it. 131. That looks like a Microsoft machine. 132 also looks like a Microsoft machine. So I'm thinking these two are the PCs in the building. 133, 135. This is the, right, so this one we can see has Raspberry Pi on it. 138, 139. I got all kinds of crazy stuff running on this number. There's my Hewlett Packard, right? So that's the HP. 156, 171. 171 doesn't show up as a Raspberry Pi. 183 shows up as a Raspberry Pi. I believe, if I'm not mistaken, was it 183? I think that's my, yeah, FlightAware. So I have a Raspberry Pi that tracks airplanes using the ADBS radio. So that's sitting underneath my desk with an antenna off the side of the house. But it shows up on the scan, so that's cool. I'm just curious about what's on the scan. So then there's something else out there that's servicing Apple files. I'm trying to think of what Apple products we have. I only have, my daughter has a laptop and an iPhone. Those are the only two things. So that's the Netgear that we have been using today. And then 211, all ports are closed on 211, which is the Kali Linux box. Okay, so from this scan, I would guess that 135 is my Raspberry Pi, right? Because it clearly states that it's a Raspberry Pi. If you only have one on your network, then hopefully that's what's showing up on your network. We have SSH and HTTP opened on that, and that 135 is my, yeah, so we use HTTP, right, is used for the Jupyter Notebooks connection, and then we've turned on SSH to remotely connect to it via SSH. All right, so then sometimes the device will not reply to an Nmap's initial scan. So instead of relying on the initial scan to discover hosts that are alive for further scanning, we can use the Nmap to scan the network by assuming all hosts are alive. So then we're going to run a different command, which will probably take a little bit longer, and probably get a different report, right? So that's the idea of this. Make sure you change your IP addressing, right, to match your own. 172, 17, 69, 0, /24. All right, I'm going to run this and see what we get. Sorry about that. I was trying to get a question. So as we're doing this, I'm thinking to myself, this is interesting because, we could use Nmap to scan a network and do all kinds of things, or see what's over there, but we really can't, adjust and then maybe fire up different services as easily as we could, say, on the Raspberry Pi. So we have this little, again, tiny, inexpensive device that I can, like we did in that very first lab, the hardening lab, where we turned on some telnet, and we can turn on FTP, and you can turn on different services, right? Don't have to really configure them, but if you turn them on, then ports get opened up, and then when we do a scan, we can use that to enhance what we're looking for, you know, and even if you had some Raspberry Pis on the network that the students can then try to find these Raspberry Pis and, right, you know, if there's, you know, FTP, maybe they can figure out how to log in anonymously to those, right, just to kind of get some hands-on, but you're not having to, you know, fire up a whole bunch of, you know, computers and things like that to do this with, you know, big expensive computers. You can do this on these inexpensive devices. So I think it's, and then the student can always have this device with them and they can plug it into their laptop, you know, and with this Kali Linux, they can immediately have a, you know, a little subnet with 256 IP addresses where they're not like scanning 65,000 with a PIPA. So again, just something to think about. I think it's, you know, it lends itself to being used in lots of scenarios and lots of situations. So this one's just looks like it came back with a, you know, all addresses, 17 hosts are up, scanned in 40 seconds. Okay. What IP address and MAC address of the Raspberry Pi? So if we look at the Raspberry Pi, so that's the 183, that's my PiAware, the one that we're looking at. The IP address is here, and the MAC address is here. Okay. So I've used Nmap to discover the Raspberry Pi on the network. And that's great as long as you don't have like 20 on the same network. And then like nobody will know what you're doing, what they're doing. All right. Awesome. All right. So compare Nmap TCP default scans and full scans. So in the terminal, start Wireshark. So I think what they want you to do, and this is where the notes are really helpful, right? Recommend that instructions include open a second terminal, right-clicking, right? By choosing, you know, so instead of don't do this in this terminal, right? Don't do this instruction in this terminal. Do it in a new terminal. Okay. So up here, I can just go right, new terminal, and then we're going to fire up Wireshark. Because if we did Wireshark in the original terminal, then I believe it keeps you from doing anything else at the terminal. The door wasn't quite closed, and the cat came in. I think I mentioned that earlier. I gotta keep it closed.
Hi, Kerry.
Yes.
By the way, the Nmap use which protocol to capture the traffic?
So this one here, I think it's just ICMP, right? That it uses in the background to do the scan, the original scan.
Right, the scan, yeah.
So it's just going to use, right? So Nmap is going to use, you know, ICMP protocols to do that part, right? I'm sure there's other things that'll do different than that later on. So I'm going to go ahead and I'm going to minimize these. Go ahead, somebody.
Oh, no, thank you.
Okay, no worries. All right. So we've got Wireshark running now. Select the ETH0 interface. Yeah, that's awesome. This is, I don't see, can I make it bigger? I should make it bigger. Does it, I don't think it'll get bigger. Using all interfaces, wire.
It is already selected.
Do what?
Yeah, it is already selected.
Okay.
0.
I'm just trying to figure that out. That's all. It says all interfaces. Oh, right there. Okay. And click capture. Is there more down below that I'm missing? Is my screen too small? So this one's using all of those. Do I just want to do just the one, or is that fine? Start this capture. All right, so there's my capture, my bad. I'm familiar with this particular interface. Apologize. So select the capture. There'll be a lot of traffic, right? The display filters them to the capture packets display just those interested in. Okay. So the interesting traffic in between the IP addresses of Kali Linux and the Raspberry Pi. Okay, so replace the address of the Raspberry Pi with the IP address. Okay, so this one here is this is a filter that we're looking for. We're just looking for a filter with the source and the destination. So that's what is that how I'm reading that? And I believe it goes there, but then we have to change the source needs to be the IP address of the Kali Linux box. So in my case, 172.17.69.211. And the destination would be 172.17.69.135. So we've turned that filter on. And then in the terminal, so we'll go back to the terminal that I closed down. We want to nmap to the address of the PL app computer, right? The Raspberry Pi. So nmap to 172, or nmap of 172.17.69.135. Okay. So we see here that it did that, and it's telling us what's there. And we should have some traffic in Wireshark here from that communication back and forth. Right? So that's what step 2 is here. That's a default scan. We're in part 2. We opened up Wireshark. We used ETH0 to do a capture. We started to capture, and then we applied a filter. This filter and this IP address should be the IP address of your Kali Linux box. And this IP address should be the IP address of your Raspberry Pi. Okay. And then the second scan here, the second step here, we actually do an nmap of that. Like we go and take a look at what's there, right? So that we can generate traffic that we can then see here in Wireshark. So review the Wireshark output. Which TCP flag is nmap using to discover the open ports? I think this may go back to the question that was asked a minute ago, right? What are we actually using here? So, does anybody have an idea? As we look at this stuff, so it looks like a SYN, right? But I'm not sure of the. Yeah, so SYN scan. Is that, if we were to look in a packet, would it give us, are these in order? It looks like they are. Okay, give us any more detail there. That's going to be it.
Should be on layer 4. The
next one down. Transmission control protocol, this one. Right. So source, destination. Right here. There's the flag, right? So most users are going to put an SYN right there. Right? So doing the SYN scan. Notice the ports that are being tested. The default nmap scan does not test all ports. How many ports does the default nmap scan test? And then they tell you, do a web search, or otherwise we're going to be counting. Count all the different ports that it's trying to scan. Does anybody have an idea on that answer? Just so we can all.
Maybe the well-known ports, I think. I guess.
Yeah, I would think the well-known ports, right?
Yeah.
So
Default
it
nmap.
should be probably from 1 to 123, maybe.
Okay.
But I don't remember.
Yes, you're right. It scans the most. So by default, nmap scans the most common 1,000 ports for each protocol. This option specifies which ports you scan, right? So then ports are ranges separated by house. So says InMap scans the most common 1,000 ports for each. So for each protocol, and when they say each protocol, they're meaning TCP and UDP, I believe, right? Oh, this is only doing a TCP scan. Or did I tell it in this? No. Okay. So I'm looking over here to see. I'm reading a thing on InMap just to see. So the InMap documentation just says it's the most common 1,000 ports for each scanned protocol. If you use a -F, it reduces it to 100. Right, so a -F on the scan. And that's if you're using a command line. And if we're using a graphical interface, we'd have to do some kind of setting change. Look at the results of the InMap in the terminal. What ports are identified in the terminal? Right, so if we go back to my terminal, right, we identified SSH and HTTP. Those are the two that we identified. And then the other 998 ports were closed. We probably could have got our answer from right there too, right? There's 1,000 ports being scanned. All right, InMap TCP, full TCP scan. So then from the command line, right, InMap-P, and we're going to tell it what ports to do. 1, 2, and we did this scan the other day, I remember, right, where we told it scan everything for that particular IP address. Okay. So the default scan is going to get the most common stuff, but if you have something that's not common, then it won't pick it up, right? So I'm curious if we were to run, I kind of want to run the scan against the two scans. I want to run against the 171, right, where I put the bit warden and see what kind of results come back. Do those extra ports that mine's not functioning, but to do the extra ports that we opened up, will they show up, right? So 65,535 closed ports, SSH, HTTP. It took 29 seconds to do that scan versus 0.48 seconds on the first scan. Okay, now my experiment now is now 171, right? I have a 171 out there, and we can see SSH, HTTP, HTTPS, VNC is open, and the CS listener is open. And you can see that it's not just ports 1 through 1,000. It's picking some common ports. So TCP or VNC apparently is a common port. CS listener, that's that container, right? The portainer is on 9,000. So then I'm also now curious, if we changed it and did all of the ports, are there any uncommon ports, like ports that are not here, that would show up in a second scan? Right? And this is I think this is a fun exercise. Like if you do a project where you're opening up ports for web servers or you're turning on services, you can have, once that Raspberry is set up and running, you can have the students scan it to see what ports are there, what ports need to be opened. We kind of decide from there. So this one doesn't look like there's anything beyond those original set of ports. I was just curious. I didn't know what we would come up against, but all right. So notice that you're saying yes.
Okay, it looks like it is using TCP, not ICMP. I also noticed that the port numbers are being changed. It looks like Nmap is sending one TCP request with port number 1 and then number 2 and number 3 and so on until it kind of exhausts all the numbers that you put in the command.
Yeah, so all of these messages here, them trying to, it just uses, yeah, you're right, TCP, and it just pings each, I don't know, ping's not the right word. Like it tries to see if that port is alive, right? To see if it gets a response from that report.
Yeah, I think it is sending a sync request, trying to see if it can establish a connection. If it gets a reset back, that means the connection to that port is not allowed. Then it knows that port is available. If it doesn't get any reset back from that port, it knows that port doesn't exist.
Right. So then, like, this is what you're talking about right here. So we got an RST back, right, from 22.
Right.
So it's like, okay, I know that that one is an available port. And here's a return from 80, right?
Right.
And then what were the other ports on this one? I think those are the only two on that board. I haven't been tracking the other one that has the 5 on it, but okay. So yeah, so to clarify, right, we're using TCP using a SYN, right? And we're looking for it to respond to each of the different port numbers. And you can see looks like the common port numbers, right? Here's all the common port numbers that it's sending to, right?
Correct.
By default, those basic ports. And then I think once we get into where we told it to run all of them, it just runs all of them, right? Just tons and tons of 65,000 packets that went out to get the same 2 responses back. But that's also, it's picking up all these weird, right? So if you have something set up on a weird port, the more expansive scan will find those ports, right? That -P scan will find them. Awesome, right? So that's good. So perform an Nmap UDP scan, right? So if we want to do, start a new capture. So we want to, over here, let's stop capturing that. Continue without saving. Oh, I didn't reset it. So, oh, it's fine. Oh, it's only going to show us UDP if we do this here. So is it capture? Okay, this is me. I think when we do this, is it only showing us TCP and not UDP? Is that what, did we filter that out? And was UDP happening all the time? Because this just says start a new Wireshark capture, continue without saving, right? So do that, continue without saving. We're running a scan, and then it's asking us to, so the source there, we do ampersand, and then UDP. So we turn on UDP, and then we do an Nmap that's doing a UDP. Okay, so right now we just got from our source, actually, that source is the UDP traffic generated by the Raspberry Pi. So we're in 211 is not the one I want to use, 135, right? You want to do the Raspberry Pi for this one. And we're telling it, right, the source, anything that comes from this device, which is my Raspberry Pi, that is UDP. Okay, so we have the scan running. We'll apply that here. We have the scan running, and we want to then, at this point now, run an Nmap. And the flags are going to be dash lowercase s, uppercase U, dash F, uppercase. And we want to apply that to 135. Right? Yeah. So we're doing a UDP scan of 135. Right, this one is using ICMP. I'll wait for that to finish. It'll take a few minutes, but look at the Wireshark capture. As you scroll down the packets, you'll see the destination unreachable on different ports and any port is closed. How many UDP ports are there? How many UDP ports does it scan? Nmap has told us it scans 1,000. And I'm assuming we have 65,000. 535, like we have with TCP. Somebody can correct me if I'm mistaken. I don't know that answer. So, I am making an educated guess. So, I don't mess with UDP much. Just don't care. Sorry, that was a bad network joke, right?
I think the number of available ports is 2 bytes, which is 65,536. Some of these ports could be TCP and some of them could be UDP.
Okay. Awesome. We're just waiting for that scan to finish. Oh, it did finish right there. So awesome. We have, we only scanned, right? So this scan, I think that -F, right? The -F scans 100 ports. And I remember that from reading the explanation here. So let's throw that explanation into the chat, and then let's throw this explanation onto our workshop page here. So that's where I found the information about how many ports are scanned, and I remember seeing if you put a -F, it limits it to 100. Okay, so the -F here is 100, and then I'm assuming, I don't know what the -S does, but the U is going to set the UDP. Right? So S is going to have something to do with maybe source, or let me look, it's over here somewhere. Get the port range. Fast, that goes down to 100. Don't randomize. So there's another option that's not on this page that explains what the S is doing. Oh, here we go, such as SS, SF. So at least one TCP scan. Note, to scan both UDP and TCP, you have to specify the -SU and at least one TCP scan type. So SU is scanning UDP. If I wanted to scan both, I would have to do an SS, SF, or an ST in addition to the SU to do the scans, to do both scans at the same time. Because we're separating them out, we don't need to worry about it. But we have it here, and it ran 100 of the most common ports. And in the process, it found on my Raspberry Pi 68, right? So DHCP, and then 5353, which is 0 config. All right, awesome. How many ports are there? Right. What kind of ports are open? What does it mean, the -F? We've already kind of looked that up. Stop Wireshark capture and clear the filter. Okay. Yes, ma'am. Will do. Stop. Clear the filter. Perform Nmap OS and service footprinting. So part 4. I always find these fun because I'm not obviously not that good at Wireshark, you can tell. The more of these I do, the better I get it. I get better over time, like wine. Nmap can guess the operating system of the device based on its responses. So start a Wireshark capture, click continue without saving. So we're going to start that, continue without saving. Apply the filter in Wireshark. Okay, so we're going to go back to the filter where we're looking at the communications between the two machines. So between, in my case, 172.17.69.2.11 and 172.17.69.1.3.5. So I'm looking at communications between those two devices. Okay. And then the -O, right, is going to do this OS footprinting for us. So we're going to Nmap -O, it's like a capital O, and then 172.17.69.0 / I don't need a /. Oh, I'm going to the exact machine, 135. All right, so we're going to try to figure out all right, so OS detection performed. Please report any incorrect results in map. So, oh, here we go. Right up here, it's a Linux 3x, 4x. So it found it as a Linux machine. It also, because of the MAC address, we can see that's a Raspberry Pi. What operating system did Nmap guess? Linux, right? Which is correct. Look at the packets in Wireshark. What protocols are used to determine the OS? So it looks like TCP sends again. Yeah. So like you said earlier, just trying to establish a connection to see if it gets a response. And then based on the responses, it makes a guess. All right, awesome. Which we can sometimes identify a device by looking at the time to live. Oh, nice. So yes, we're gonna we're saving this one. Thank you, John. So the cheat sheet, I'm gonna put it up on the. Not we were looking at the Linux one earlier. Here's the Nmap cheat sheet. Oops, no, let me grab it from the right place. Okay, boom, awesome. So we have now on the, if you're on the Google Drive, right, level up your cyber skills folder, you should see a Linux cheat sheet and an Nmap cheat sheet. Right, we sometimes identify a device by looking at the time to live field in the of the local ping response, which varies by device. Right, so in the Kali terminal, we can ping this. We're going to ping this with four pings, right? 4 packets, and then we're going to kind of look at see what's going on there. Okay, so. So when I say when I'm laughing at John's response, and then the next one, Mike, which command are you getting node targets were specified?
the operating system.
This one here. Did you change the IP address to match the IP address of your current Raspberry Pi?
Yep.
So you put in nmap, and this is a capital O?
Is it capital O?
Mm-hmm.
I'll try capital.
Yes, no? Maybe?
Yep.
Cool. Excellent. All right, so I'm on part 4, step 1, item D, right? They want us to ping and look at the time, the TTL responses to see if we can see a similar time to live response here, okay? So we're doing, right, 4 pings, and they're saying if you look here, right, you can see the 64s, time to live, right? So sometimes that helps give us a clue, right? To test that theory, right? So let's take a look at I'm on 69.132. So let's ping 132 and look at that. The time to live 128. That's a Windows response. Right? Windows response. We're not going to talk about the fact that I don't have Cisco gear on my network. Moving on. Use nmap to find services versions. Okay, there's step 2. Nmap has a built-in database of about 2,200 well-known services. Okay, so start a new Wireshark capture. Cool. The -A option scanning IP addresses of your Raspberry Pi. Oh, let's go see what this does. Excellent. So stop the capture, start the capture, continue without saving. We're still leaving our filter as is. We're going to go back to our terminal where we run all of our nmap from. We're going to run nmap -A directed at my Raspberry Pi. So the -A option should help us identify services. That's how I'm understanding this. So OS and services detection performed. Please report any. So, oh wow, look at that. All right, so nmap right here. TCP SSH is open. Looks like it even gives us the version of OpenSSH that we're using and the version of the OS. And then keys. 80 is open as well, right? So Tornado, I guess that's the Tornado server is running, and that's the Jupyter Notebook stuff, right? So there's a Tornado server running, 4.51, and the title is Jupyter Notebook, which is the software that we're, or the IDE that we're running. All right, so those are the 2 things that are running, 22 and 80, but there's a whole lot more information about it here, right? Lots of good, right? It's one of those things I think, you know, as you go through this, I mean, if there's a vulnerability with Tornado 4.5.1, then this will help a hacker find that and maybe exploit that. So I don't know, again, another one of those awareness, right? It's an awareness lab. All of these labs to me are awareness labs. The more you play with this, you're like, what the, really? That's all, I mean, that's what you have to do to get this information. And like, you can see this information, you know, plain as day, and yeah, pretty good stuff. All right. Cool. we made it through a lab and we didn't have a problem. That is awesome. All right, so that's the port scanning lab, the lab where we're just basically gonna, take a look at what's going on the Raspberry Pi. I looked at both. I'm curious now. Now that I say that, I don't want to be done yet. I want to do my other box to see what kind of services it shows up as running on the regular Raspberry Pi, right? But I think that's a really interesting, introduction, right, to how these things work. And again, we're using the Raspberry Pi as the target. So as long as we can plug a Raspberry Pi into the network, into the computer, we'll be able to run these, run this network, run these scans and make things happen. Waiting for the scan to finish. Close that down while we're waiting. So the last one ran in 9.17 seconds. This one is taking sweet time.
Gary, are you using a Raspberry Pi 3B Plus or a 4 doing this?
So Kali Linux is on my local desk. I'm using a 3. Well, this is now scanned. This one just scanned a 4. The other scan was a 3. Right. So this first scan up here, the 135, that's a 3. The 171, that's a 4.
Okay.
So I'm using kind of both. 171, I've got 22 open, right? Because we opened that one up. I've got 80 open, and that's running the NGINX. And then, oh, look at that. The title is Bad Gateway. This thing just doesn't like me. That's rude. 443. Did not follow redirect. So there's something goofy. Yeah, so there's something's wrong with whatever I did to set it up. I messed up something. 5900. There's my VNC for that particular unit, right? 9000. That's the Portainer port that we have open. No, it shouldn't be a problem.
So this lab is nice if we put it on a sandbox, an isolated network, and just do it without the PL app.
Yeah, no, I've done it on both of my machines today. Like I just, pinged my Raspberry. But what's cool is that, like, if you think back to like that very first lab, the harden the Raspberry Pi lab, and we fired up like a FTP server, and you fired up a Telnet server. Like, there's other ones where you can fire up DNS. You don't have to configure them, but if you fire up, like if you start DNS, like those ports open up, right? So that would be a really cool thing to have them do, like, open these up, turn on these programs, right? System control, start, right? DHCP, DNS, whatever, and then have them scan stuff, and then, turn those off and turn on others and have them scan again and then compare. And it'll be a lot, yeah, because you can do a ton with this, and you can see that there's a ton of information that's being shared. So, and then, what to do with this information, what can we, right? What would a hacker do with this information, right? So, yeah, I don't know. I think it's a fun little experiment. Again, awareness, right? Getting the students to think through, it's one thing to say, well, this could happen, right? And, read about it. but it's another thing to actually have a device on your desk and actually do it, right? And actually see the ports and turn ports, turn on services and see ports open up, and then turn off services and see ports shut down, that kind of thing. So that's the part I like about it. Like, 'cause you have that, again, tactile, like that's a tactile thing for me. I probably could set up some complicated thing that I could, but with other computers, that would be really difficult. But with the Raspberry, I could just move it around. As long as I have an Ethernet port on my laptop or desktop, right, you can connect them. So technically, right, even if you have, I don't know how you have your computer set up, but if for example, in my environment, I could have them install, VirtualBox and install a VM, a Kali Linux VM inside of that VirtualBox, and that would be part of my image for my my classroom. So I could do that, and then I could, they could simply, plug in USB Ethernets and then plug the Raspberry into that and do all of this without affecting anybody's networks. But anyways, there's lots of options that we have for that. I mean, I just think there's a ton of options. We're using, Oracle VirtualBox and a virtualized Kali Linux to connect to this Raspberry. Like Nmap, you can put Nmap on a regular PC. Wireshark goes on a regular PC, so you don't even, if you wanted to do these things, you wouldn't even need Kali for that. Right? You can just have those installed as part of an image for that purpose. I don't know. Anyways, cool. Yeah, so we found out, I went and looked at both of those. We don't need the PL app for this lab at all. Like, you don't really need it for that lab at all. You would need, right, as long as you have a Raspberry Pi on a network that, hands out IP addresses, then you should be in good shape. So the other thing you could actually, now that I'm thinking about it, I'm sorry, I just kind of keep thinking like, okay, well, a student could, right, if they have a laptop and you can have them set up a Kali Linux box like this one, and you can have them statically assign an IP address on a private subnet, doesn't matter what it is. And then they could also statically assign an IP address to the Raspberry Pi, right? And then anytime they plug them together on a wire, just directly connected to each other, they're both going to be able to communicate with each other on that, on that connection. So that would be another way to do that. Just use static and not use DHCP. Okay, so a couple options there. So let's so this is the first, after lunch, the break needs to be a little bit sooner, right, than later. so let's take a break here, and when we get back, we're going to attempt this packet crafting. I looked at it over the lunch hour, and it looks like it's doable. We'll see what we can get accomplished. But let's do a 10-minute break, right? And we'll come back and we'll work on the packet crafting. And these are all 3 labs that we worked on today are from the chapter 4 of the IoT security class, and it's all communications, like what can happen, what happens at the communications layer. All right. Excellent. We'll see you in 10. All right, then. I extended it 2 extra minutes because I spilled a 2-pound box of spaghetti all over the floor. The noodles everywhere. I moved it. The box was open. Didn't realize it. Okay, let's close down all the things that we had running on the Kali Linux box, so we can kind of start this next exercise. So next exercise is 4226, also from the IoT security course. Packet crafting to exploit unsecured ports. So using HPing3 to port scan, crafting different types of ICMP messages, and launching DOS attacks. Fun stuff. I'm going to click on Tony's link here. Download. See. Switch over to our drop it. So an HP3, HPing3 cheat sheet. Thanks, Tony. Like I said, tons of resources. So thanks for sharing, everybody. Everybody that has these resources, these are awesome, right? This is good. I love it. All right. So it's a tool used to send custom crafted TCP/IP packets to network target in order to elicit a response. Okay. It's pretty cool. You can also, this is also another one of those things where you don't need Kali again. So do this because you can install HPing on your. I don't know if it's a. Will it do a Windows deal? Works on Unix-like systems, so yeah, Mac OS. Well, it says Windows. Interesting. So it looks like you can, if you have a Windows machine, you can run it there. So again, you know, this kind of, you don't have to have that Kali in the background, but I think one of the nice things about like Kali Linux is that it has a ton of tools already done, already ready, already there, updated, like constantly updated for you, that kind of thing. So something to consider. But I think this, let's take a look real quick. I'm not gonna do the lab yet. I just want to kind of look through, like, you know, we're doing, well, we're not going to do that, but these are all Wireshark, same kind of thing that we were doing before, right? And we're using HPing from Kali. So I think you can do this against your regular Raspberry Pi. I don't think it has to be, right? Unless they've, you know, turned on something or off something that we may want to consider later on. But let's take a look at that. Like, I think kind of, you know, Tony, kind of in your vein, like, can we do these without the PL app? And I really, unfortunately, we need to kind of move away from the PL app, but I think the idea of having this on a separate network and things, maybe we want to kind of consider how we do that, if possible, right? I think this Kali Linux distro is great, and I have no problem with the running the DHCP server, you know, unless I'm trying to do a Zoom call with it, and it just doesn't work that way. So, all right, so let's take a look. We need the Raspberry Pi, we need a Kali Linux, we need network connectivity between the two. Step one, or part one, A, B, C, D, E. We've done all of those in the last lab, right? So you should already, right? You should already know your IP address for your Kali Linux box. You should already know your address for your Raspberry Pi box. Okay. They want us to open the man page and review the features and options that are available. Okay. And I think we can come all the way down to here, right? So this would be like J down here. Like, this is, what is this going to do, right? So that's where the man pages would make sense. We'll go ahead and bring it up. HPing. We're bringing in HP3, right? HPing 3. All right. So let's just take a look real quick. Like, so -8. There's a -8, a -S, a -1. So I see a little C there. That's not the one I'm looking at on the right-hand side. Don't see a dash I, dash B, dash D. They pick all the things that are really hard. Well, they picked all the odd ones. Dash 8s, right? Scan mode. Option expects an argument that describes groups of ports to scan. Okay, so dash 8 and then dash scan. I'm looking to see there's a dash A. So dash A is use this option in order to set a fake IP source address. This option ensures that the target will not gain your real IP address. I said yeah, real address, I guess. Nice. So look through, see if I see the result. Did I miss the S? Nope, not yet. P, S, and K. So ICMP, so dash C sets the ICMP type. So default is ICMP echo requests. So it implies that you just did dash I means ICMP. That's the dash C there. And then there's a big K, not a little K. Little S, base port, source port, HPing3 uses source port in order to guess replies sequence number. Sequence number can be computed. So this option, you are able to set a different number if you need that source port not be increased for each sent packet. Okay. Dash P sets the destination port. Will be increased for each reply received. Okay. And then I didn't remember seeing a dash S or dash 1. Not yet. All right, so the students can go through this. There's dash S. It's a send. We're going to send a send TCP flag. And then the only one that's really missing is a dash 1. And I could have missed it earlier, but I think I did. Okay, awesome. All right, so they would have to write out, you know, what the name of it is, right? And then what's going on. So excellent. We'll queue to quit that. Again, I think students need to be aware that they're going to have to use these manual pages to construct these, exactly what they're trying to do with their commands. So in Kali VM terminal, we're going to fire Wireshark. Wireshark. Oh, same error we had last time. Okay. In Wireshark, select Ethernet 0. Select it. You may have captured network traffic that is not relevant to this lab. We're going to restrict the type of packets we see using the display filter. So same kind of thing we did before. Am I missing the whole start a scan? Select ETH0 in the packet capture. You may have captured network traffic is not relevant. We're going to restrict the type. Great. Apply the filter. First craft packets to. Okay, so they missed. And here's somewhere right in here. Right, so somewhere in here it should have said like start to capture. Because if we run this command without the capture on, we're not going to see it. So I don't know if that's on the addendum or not. So and now that's just the. So which part is that one? That one is part 1. I'm not seeing it, so I just want to make sure I'm not seeing it. Everybody else is seeing it. We fire up Wireshark, but then we don't actually turn on the capture. So part 1, step I. Okay. Excellent. So I think at that point, right, we can start to capture. So if you double click on that, yeah, that's, but it still doesn't say it. That's what's, right, and a student going through this will select the Ethernet. And then, if they don't remember, if they don't remember from, from the previous assignment that you have to start to capture. Right. And you, moderator, know Wireshark tremendously better than I know Wireshark. I am but a rookie. Whereas they say in the gaming world, a noob. So, but I'm like, at least I realized I should be capturing something before we get started here. So apply the filter. Remember, right, unless you're running off of the lab environment, you need to make sure you reset your IP addresses to match the 2 machines, your Kali Linux box and your Raspberry Pi. Okay. So in my case, 172.17.69.135 is my Raspberry Pi, and 211 is my Kali Linux box. Okay, so now we're filtering. And then I think this is where they said, like in the like what's wrong with the lab, recommend the instructions say open a second Kali Linux terminal, right? Because we really can't go back to the terminal that Wireshark is running in and do anything with it, right? So, and if you do anything there, you would actually shut off Wireshark. So you have to actually open up a second terminal, right? And run the hping 3 -8 0 to 100 capital S, and then we're directing this to the Raspberry Pi that we have on our network. So hping 3 -8 0 to 100 capital S 172, right, whatever your IP is. All right. Refer to the Wireshark capture, the man pages, and other sources on the internet. What do the options 8, 0 to 100, and S do? So as we go through, we already kind of looked those up, but we went through that. So they're having this run that scan and then go through Wireshark. You're going to have them go through Wireshark and try to figure out what that what this did. Okay, what those 3 pieces are doing. All right. What ports are shown as opens? We can take a look at that on this side. Nope, not that one. This one. Excellent. So 22 and 80, right? So the SSH that we have open and the 80 that we have open for the Jupyter Notebook. Okay. Excellent. Right, so I think I need that one open. Okay. What TCP flag was set in the show and was set in the shown in Wireshark? That, wow. I am thinking this. Something wrong there. Nice. Alex spent his lunch doing this. Good. So add this to your display filter. So we want to add something to the display filter. Add TCPC flags dot reset equal 1. That.
Yes.
Okay. Did I miss that, or is that just something you want me to add?
No, if you add it, no, if you add it, then you can see where you
Oh,
get all
okay.
the reset. Yeah.
Awesome. All right. Oh, so that's only going to send those two that opened, right? The resets.
Yeah.
Okay, gotcha. I love it. Okay, very cool. So those are the two that were set, right? So 22 and 8. Excellent. So crafting different types of ICMP messages. This is all new to me, people. This is a new one. So ICMP has different message types that you can, okay, that kind of understand, right? Example, message type 8, echo, requested 0, echo reply, are used by the TCP pool ping, right? So that I got that. However, if the target is configured not to respond to ICMP messages, you can use other ICMP messages types to attempt to get a response. All right. So then they want us to open up the manual for ICMP. And then what is the okay, that's it. Got it. We'll do that. Just, what? It makes sense in a minute. So first of all, we're going to start messing with stuff here in a second, but they want us to kind of look up front, like, you know, we're looking at the the manual for ICMP. So what works and what doesn't work. Right, it's set in RFC 792. Okay, what is the RFC? And then one thing I like to do when we run across this in any of my courses, I have them go out and find this and start to understand that everything we do in the networking world has some document that defines how we're to do it, right? So this is just an example of that. So I like my students to go out and kind of look through this, and we kind of have a discussion about it and talk about it. But this one's what, 21 pages, it's not bad. The scary one is when you get to the power management RFC for Windows, and it's like, I don't know, 900 pages, it feels like. It's like a humongous document. It's crazy big. But I keep, like I say, I refer my students back to this. So if I have a student 3 or 4 times, they've probably seen, you know, a half a dozen of these. Do we do a lot with them right during the class? Not really. But I want them to see this and understand that over time, right? Or not over time, but everything that we do in our profession, right? In the IT and networking and all these things, everything is based on a standard document somewhere, right? And in this case, it's an RFC that defines how ICMP works, right? So pretty cool stuff. And then you can see that, you know, it shows you which ones that updated, which ones were replaced. And then actually this has been updated by 4 others. There's 4 other documents. So then, you know, this whole document trail, this hyperlink rabbit hole that we can kind of go down, you know, and there's some students that really kind of get into, like, they get really interested in, like, you know, all of the stuff that goes on behind the scenes, right? So, and then those are the ones that, you know, are going to be really good at this kind of stuff. But just I don't know, it's kind of a sidetrack. I just want you guys, you know, if you haven't done that before, I think it's really interesting to have the students go through one of these. This one's not too bad. It's only 21 pages, so we're not going to be spending a ton of time on that. But they have us go out and check that, and then that literally is the answer. That's the only thing they want us to answer, right? So they have us go look at this man page and then understand that, hey, defined by RFC 792. Okay. So yeah. So start the Wireshark. We're going to start a new capture. So I'm going to kill that capture, start a capture, continue without saving. Right. And then we're going to run a separate hping command. So a new hping command. So on the man page, we're going to just get rid of that. Now I want to go back, right? Because right here, we're about to tell it what to do. And we could have looked that up. Right, so there should be maybe, maybe not. There should be a way for us to see what they mean by 13. I see 0, right? I don't see a 13 there. And that may be something we need to go dig into the other document, right? The other man page to get a more defined answer for what are we doing here, right? There's a -1 and then there's -C 13. And I know we started looking at those a minute ago, but that's the idea. HPing 3. So we're going to do a -1, and we're going, our target's going to be 172.17.69.135, which in my case is my Raspberry Pi, -C 13. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was thinking maybe C was a count, but it's not. We're doing a bunch of stuff. All right, so we're actually, oh look, it tells you right there. Like I skip right to the command and start trying to figure it out. -1 to scan an ICMP mode. Great. Add a scan target and then enter the -C followed by 13 to indicate that ICMP type 13 timestamp request messages should be sent. I was trying to figure out what type 13 is. I guess a timestamp. I'm looking for, seeing if it will respond to a request for a timestamp. I'm going to remove the RST just to see if there's something different here now. So now we're seeing all these ICMP packets, timestamp requests. While it's scanning, sweet, thank you. This is Reza, timestamp here. So here's all the different types of ICMP parameters that we can send off. I'm going to drop that into our day 3 group learning. We're still cruising. Still cruising. There's the HP. All right, so then doing that. So we're going to do that. Review the WASTC results and confirm that TCP ICMP timestamp request packets were sent out to the stop the request. Control C. Oh, it's going to keep on trucking. Let's go. Control C. So it is sending timestamps. We can see that, right? Timestamp requests constantly, right? And right, and oh, this is interesting too. We get this time to live, right? 64. So we know we're dealing with a Linux system. We are learning all kinds of good stuff today. Okay. We're going to then now start a new one, right? So we've done that. We sent a timestamp request to see if we could get a response out of the computer. We didn't get a response. So let's stop this. We're going to continue with a new scan, continue without saving. Prompted by apply the following filter. So we're going to do a new filter. Isn't that what we already have? We already have this. Source destination. We already done. I've already done that. We're good. Okay, repeat that ping command above, but this time set the ICMP code to 17. 17 being address mask requests. It's a deprecated command, but we're going to try it anyway. So we're going to go back over here and do up arrow, and we're going to change this to 17 and see if we get, also got some stuff going on over here. So address mask requests, not getting any responses, right? So we're not getting any responses, but we're able to, I'm going to Control C now. So we're able to modify the type of request that we're sending, right?
I think you're not getting any responses because your source is set to your Kali. If you change your source to your Raspberry Pi, you should be able to see the other ICMP echo request.
Did I do this backwards here?
No. I'm just saying if you want to see any, I guess, reply back from the host, you need to remove that IP source, I guess. Then you can see all the.
But then we wouldn't have seen the resets from earlier, would we? I'm curious. I don't know. It seems like, right? Because this is like we're seeing these packets go out, but like earlier we saw packets go out and we saw the responses come back. No, right?
Well,
this one right here. Like if we do this, we can run this command again. So if we do this, go ahead. I'm trying to understand that. So like, so HP3, so we did this command earlier and right, we got those, and then here's the results, right, of all of that. And right, there's that RST. That one right there for 80. And then there should be one for 22 here, right?
Yeah,
So,
if you and if display filter, if you just type ICMP, if you just type ICMP
here.
Yep. Hit the enter key, and then if you scroll down, yeah, you should be able to see the.
Oh, those unreachables. Okay.
You should be able to see the request and reply.
Yeah, so that's why would they then have us like they literally just right above this said just do this, like tell we're only seeing, like you said, we're only seeing the outbounds. That makes sense. I mean, it makes sense. I was just trying to understand. And this does the same thing. Like we're only seeing the outbounds. We're not seeing any of the replies to see if our our mask request, right, is coming back as host unreachable. That makes sense. Well, that's a response from my router. So now, hold on a second. Ping dash is it C4 172.17.69.135. Okay, it's there. And those should have shown two too, right? So here's the pings and the replies, right? Request and reply, request and reply. I find it interesting that my router stepped in and told us that that destination is unreachable. It says port unreachable, so maybe we don't have that, like address mask isn't running on this network or something, or not running on that machine, but it's the router that responded. Right? That was, I don't know, that to me is kind of strange. Maybe I'm being odd. And then I'm going to do that 13 one over again, right? So let's do the 13 one over again. So then we get the same thing, like the router. Well, the router says destination unreachable, and then I've got a timestamp request and a reply, right? So my Raspberry is replying to the timestamp request. Cool. Okay. Yeah, I like that. So that's, to me, that then means like the way they've written this instruction, like that piece there, you limit yourself to just seeing that you're sending the packets out, but not that you're getting a reply. Right. Which,
Right.
I don't know, if you're trying to get a machine to reply to you, you'd want to see the reply, wouldn't you? I don't know. That's just me thinking out loud. I should probably not do that very often. Okay, awesome. So we were able to see, right, that I was able to send things out, right? And now, right, that we've corrected the filter to see just ICMP, we can see the request and the reply from the machines there. So, and it actually, there's your timestamp right there. So that's in this particular reply packet. You can see the timestamp reply back from them. So pretty cool. And then, so if we would jump down to another one, right, so this one, 21 hours, 56 minutes, 10.103 seconds. And if I jump up, 6.1 seconds. Right, so you can see it responding the way it's supposed to. Awesome. Okay. Very cool. So we're using HPing now instead of, I mean, Nmap is going to help us find things and find ports and things like that. And this is, right, HPing is allowing us to try to establish communications, right? Doing some port scanning. And then we played around with a couple different messages, right? We did the timestamp 13 and we did 17 address mask requests. We could try, you know, sending other ones as well to see what we can come up with, right? So the next piece we're going to do is we're going to launch a DOS attack. Sweet. Let's try this, see what happens. All right. So I've got nothing going on there. I'm going to go and start a new capture. And I don't have, well, I have the one filter that we're using, ICMP. So launch against ports you found previously in this lab using each ping for this purpose. Okay, we test how the network will react. Okay, so start Wireshark, capture, start without saving. To see two-way traffic between the two, enter TCP as the display filter. So we want to just see the TCP traffic. Okay, awesome. Oh, I haven't started it yet. I'm like, why is that all weird? So continue without saving. There we go. So this, we're showing TCP traffic on the network, right? In Kali Linux, we're going to enter the XHP3 command to send a DOS attack. All right, let's do it. So this is kind of the stuff where if you did this on your regular school network, you would then start to get, you start to have issues, I think. 172.17.69. 135 is my Raspberry -P 88 -- flood. Oops. Enter. No replies will be shown. And then that Wireshark, what type of TCP does it send in this DOS attack? Go all the way down here. Holy cow. TCP. We're sending us SYN. And the destination port 88. And our computer is replying with a reset acknowledgement. So we're sending, are we sending a, somebody can help me here, but I think we're sending a packet that tells the computer we're done talking to it. Like it's not the proper sequence. Like it's a send package out of sequence. That's what I'm thinking. And if you didn't already know this, in the drive that I shared with you, the internet security class resources, there should be oh, that's not the right one. No, it is. It says all of them in one big book.
Okay, I'm looking at Wireshark. It looks like you are trying to establish a TCP connection to every available port. So eventually you exhaust all the ports on the server and you bring the services down on the server. I think that's what it's trying to do by flooding the network.
All right.
Yeah, look at the port numbers on the destination. I mean, it's going up by one. You see 42, 381, 382, 384, and so forth.
Right. Okay.
So you're sending a sync request and you're getting, I guess, acknowledgement back and expecting to send something to the server, and you're not sending. So you're basically tying up the port on the server.
Yeah. So it looks like, right. You're correct. We're sending. I think we're sending to 88, but we're incrementing our port numbers by one. So instead of it being a 1-to-1, like I'm going to talk to you on this port only, I send you this send request, right, from this port to your port 88, and then I ignore that and I send you another one from 381 to 88, and then I send you another one from 382 to 88, right? So we're only hitting on the Raspberry Pi port 88, but we're sending it from every single port we have available. And we're not acknowledging any of it. We're just sending the request, and it's trying to, like, it tries to get back to me, but I'm not saying anything. I'm just ignoring it. The source port is specified for the scan and does not increment. Wireshark reports that the TCP port numbers are reused, right? So we're basically, like, we're continuing to send to the 88 port on the machine, on the Raspberry, but we increment by one on our machine and don't reply to anything. Right, so we're flooding it by sending it, 60-some thousand packages, right? All that it expects to respond to, but we don't get a response, but we don't send a response. Yes, no, maybe so, kind of, sort of.
Yeah, I think you're right, and my Kali Linux is kind of frozen. I can't do anything. I'm
Yeah,
not
I had
sure
to Control C out of it to stop sending packages.
Yeah.
Right, because it's still sending. It was continually sending packages.
Right.
Mike let us know that in the chat. And then on the right-hand side, right, this kind of, there are instructor manuals that will help you answer those questions. I try to not, I don't, for these labs, I don't look at them. Probably should. It would sound more intelligent. That's not the point today. So, all right. So we just executed a DOS attack on our Raspberry Pi from our Kali Linux box on the network, and we flooded it with thousands and thousands of packages. I don't even know. Oh, I need to get this where I can see the whole screen better, so we can see the number of packages.
I think it would be interesting to see if you can do anything on your Raspberry Pi.
Yeah, at that point, like, could you try? Yeah, so let's do this. That's really good. Let's, I'm gonna go ahead and send that again. All right. So I'm gonna go ahead and send this flood. This is against my PL app. Okay. So I should be flooding it right now. And if we go look over here, there's a bunch. So I think it is. I'll move this off to the side so I can get all the way to the bottom. And so you can see that it's continually, yeah, it's continually moving. So we are continually flooding that thing. So then what I'm going to try to do, right, is can I SSH to that bad boy? Right. Looks like I can. I don't think I have the password. So I'm able to SSH to it even while I'm doing this. So maybe one computer sending a bunch of requests, that obviously wasn't enough to drop me, because I was able to do that. So I'm curious now. So if we go over here and we Control-C that, and I change, whoops, I'm going to leave that flood there, but I'm going to change it to my 171. All right, so I'm going to basically just pound the other Raspberry Pi real quick. So those aren't going to show on my, well, they will show on my thing over here. But what I want to try here is if can I establish, yeah, and I still can establish. So I'm not seeing we know a lot of stuff is getting there, right? We know a ton of stuff is getting there. You can see right here, this is 135 to 211, then down here, right? Oh, look at that. Okay, so we're getting those right resets, but we're not hurting it enough to actually stop the service. Make sense? Now, experimentation, right? So you got me curious again. Let's just stop doing that. I'm trying to look up 49, so the web interface can use port 5800. 5900. All right, so if, I don't know, instead of 88, what if I tried to flood 5900, right? Which is the 5900 is should be the VNC.
Or 22.
Or 22, like let's try 22, right? So 22. Let's try to flood 22, right? So right down here, we're flooding 22 currently. And then if I try to terminal and I try to SSH to 170, it should be carry at 171. I'm still able to get through. Interesting. Yeah, so we're flooding it, but not enough, I think, maybe. Just not enough to take it down where it can't respond, because I'm able to respond. Like it's able to respond, I'm able to log in, and we can see here that we're actually sending those requests. And then there should have been a request, a 22 request that came not from 211, but it came from, let's see if we can find it. I'm 132, so source equals 132, right? So then can we do TCP and then the and what's the right IP dot src equal 172.17.69.132. Find that. Don't see anything changing. I'm going to stop this because I think it's killing our machine more than it's killing the VM more than it's killing the Raspberry. That's what it seems like. Is that should do it, right? Or if I just did IP source equals that. Yeah, it literally is. It's hurting the sending that information is actually hurting the so it's not 172.17. Okay, I don't understand what's going on there. I would imagine. What I think is funny is I think it's actually hurting the Kali Linux VM more than it actually is hurting the Raspberry Pis. Like when we were doing that.
I had to kill Kali. Yeah, I think it's better to run the H pin on a different computer, probably another. I'm gonna try that with another
Okay.
to do that, because it's actually killed my. I mean, killed the attacker.
It hurts. Yeah, the attackers. Like, here, let me take myself out. Right?
Yes, basically.
So, and then I'm trying to see. I'm like, I just wanted to see in this thing. It didn't pick up that I was using a terminal on my machine, and I connected with 22. Right. So, like, I connected here, and that should have shown up. Like, and I'm just saying anything with the source of this computer, right? And it's still not. So that's kind of a strange thing too. I don't know. I mean, at this point, we're kind of playing around with the end of this with this lab here, but I find it funny that the flood, when I ran the flood, it actually hosed up the Kali Linux virtual machine more than it. Like, I was able to log in and connect and do all the things I needed to regularly do on the Raspberries without even noticing that there was a problem. Like, I logged in and it was good. So so we did a DOS attack, but we only took ourselves out. So that's good example. What is this one? So this one, we're going to send us an ICMP flood attack. A robustness experiment. Interesting. Okay. So the last one that we want to do here. So we actually still let's get rid of that. Let's stop whatever scans are going. Let's ICMP. Yeah, this machine is acting funny now. I'm not running anything in the background. Let's go ahead and let's have you tried turning it off and on again? See, I was able to get the VNC while that thing was running. Man, that machine does not. So let's just power off the machine. We hosed that machine bad. That's the wrong machine. The other machine should have been the one that had the problems. I was able to SSH to both machines and VNC to one of the machines while the attacks were happening. So they didn't do any damage. They didn't take anything offline. So I'll restart this and see if we can't. I want to run that last ICMP and see if it does anything different. Like, does it cause more issues? The other one, we were just hitting one port, right? I wonder if you could you do a range of ports? And did I type this in and did I miss the -K? I don't remember typing in a -K. I think I may have sent the command wrong. Okay. We're back. First thing I want to do, fire this up. And we want to fire Wireshark. All right. Thank you very much. And then we need to open up a new terminal. And I am going to, oh, we only ran this one. So we ran that first one. Stop the flood, start a new capture. We're going to send a DOS land attack. This attack sends packets with the same source IP port combination at the destination IP port. In other words, the source IP and address is spoofed by replacing the Kali Linux VM address with another value in the packets. Okay. So we didn't run this one. I want to run. No, I don't need to run that one anymore. Let's do this one. All right, so then we need to change. All right, so this is like, if I'm reading this right, we're sending a ping, like a flood that looks like it's coming from itself. Like, so it's going to talk to itself, right? So on all these examples, the .13 is the Raspberry Pi. So we're going to just change the IP address to both Raspberry Pi addresses. Or the one IP 172.17.69.135. And we have a capture running. No, we do not. Run the capture. Start the capture. Is this a TCP thing or an IP thing? We'll just let it run and see what happens. Enter. All right, so if we go to the bottom of this is TCP. Port numbers reused. So you see it's looking like it's coming from itself to itself, from itself to itself. So we're going to do our test again, right? So I'm able to still connect, but I'm not going to log in. And I was able to log in. So that doesn't, it's not causing any damage. Control C that, so we kill that deal. So, and what they want you to see with that one is, right, the source and the destination. We've actually set those as being the same thing, so it looks like it's talking to itself. The last one. We're going to flood ICMP on port 22. Right. So let's change our filter to ICMP. And we'll stop that one. We'll start it over. That doesn't look good. Didn't like it. Again, I think these are causing more problems for the attacker than they are for the. So stop. I see. Let's start. Continue without saving.
Gary, I think
Yeah.
one of the reason Kelly is freezing is because we have a lot of I/O. I mean, this Wireshark is capturing a lot of this. So I don't think it's the tool.
I think we're just underpowered, right? We're running in a VM in a small environment.
Well, I think if we close packet Wireshark, we don't. I mean, the Kali Linux doesn't freeze anymore.
Okay.
That's one option. The other option would be, instead of using a display filter, maybe we should use a capture filter. We only filter certain data, capture certain data, rather than capturing everything and then displaying. I think it's Wireshark that is causing these issues.
Okay.
Yeah.
Yeah, I think we're just, we're using up a lot of resources, right?
Yep.
All right. So then I tried to run the last one here. And it tells me you must specify only one target host at a time. What is that? Oh, here's the problem right there. The copy didn't work very well. All right, so we're down here from our computer to that computer. We are sending let's scroll down. You can see all these crazy packets going through, right? And ICMP. So we're just doing echo requests, right? So yeah. But again, I don't know that we're sending enough to prevent a connection. And we're not. Cool. All right. But I think the idea is there, right? And we can see the packets and we can see how much we're sending and see what the responses are. And we're sending, tons and tons of packets. 357,000 packets. 400,000 packets. 410, right? 417. 427. A lot, and we're still able to communicate, which I don't know, that seems pretty good. So that we're able to withstand that. And it's a tiny, it's a tiny attack because it's a single computer, but just imagine multiple computers. Cool. All right. All right. So that is, that's that lab, right? So kind of getting the, and then they, the students can go and fill this out as they've gone through the lab. They get a better understanding. They can fill out the information a little bit better. But we've done today 3 different communication-based hacking, pen testing types of labs. We sniffed Bluetooth earlier today. This afternoon we did port scanning and packet crafting. And so I think that's those are some good examples to, again, raise that awareness, right, of our students. And the things that can happen in the background, and they can see it live, with the data here that's provided by Wireshark and Kali Linux and all the different pieces.
I just tried something I wanted to share with you. I opened a couple of terminal windows on my Kali Linux.
All right.
And I issued the same command on port 22, flooded port 22, and I got connection timeout on my Raspberry.
Oh, so you did
I tried,
multiple times?
Yes.
So something like that one?
Yes.
Okay.
Go ahead. And don't run Wireshark again. I think Wireshark is what's okay.
I'm gonna leave that in the background, right? I'm not even gonna mess with it. We're just gonna let that go. So I'm running actually, so that's an ICMP one. That's not the one we want to run, right?
No, I ran the other command, that be -S.
So the -S one here.
I think you had another one before. Yep, this one. Yep, port 22.
And you did port 22.
Yes.
So we flooded port 22 with this, and then you opened up a new terminal, and we flooded port 22 again there. So then if I go here, I'm just going to see my terminal. Right, so SSH. So I'm able to connect still. Okay. Let's
I don't know,
exit.
man.
I've only done it once. I've only done it twice. So we're just like, I want to just kind of build up to that and see what, right? So that one again. So I've got 3 terminal sessions here running that.
And I'm doing everything on virtual environment, so maybe
Okay.
mine my network is a little bit slower than yours.
Okay, so let's exit out of that. Terminal. So at some point, if I do this too many times and we get disconnected, then we're done for the day at that point. So, because I killed my machines, I'm still able. I'm still able. I really want to see where it doesn't let me connect. We should have Laura come in and show us one command that will do it.
Kerry, you're trying to establish SSS to a different machine. I mean, I see that you're using a 171 for the last octet, but when you're SSHing to a different machine.
Am I?
Can you go back to your Kali Linux? Let me see which IP address you're. Can you go back to the other terminal? So that is 171.
Oh, that one I didn't want to do that one. No. So 171 I did 171.
Yeah, I see
And
they're
then
all
130. I got 2 different ones going on. So
okay.
that's what's going on. So thanks for, yeah. So let's do this. Let me kill the 135 one here. Right. So 135, we'll turn that one off. This is 171. I'm going to minimize that one. That one's still running. 171, that one's still running. Let's just do 171 here.
And that's not the command you want. You want the other command, -s.
Yeah.
There you go.
But I want the one that has the port 22, 171 flood. Okay. Run that one. So now I'm running 3, I believe. I'm going to exit out and we're going to connect to 171. I'm able to connect. So this is that's 171. It's 171. And then the other terminal, which is off the edge of the page, 171 as well. So let's open up another terminal. And flood 171. Yeah, I'm still able to get through. I was hoping that we would be able to drop this sucker. That's part of the fun of this, right? Especially when you're playing with your own stuff. All right, I've got it running 4 different times. I'm not able to get it to crush. I think maybe if I, if I put HPing on my PC and HP on my wife's PC and we did it from multiple machines, maybe we could probably get it to go that way. But for some reason, I'm not able to get it to get it enough. But I think the more the more you stack that up, the better, the more you're going to disable its ability to respond. So, all right. That is what it is. Like I was running it multiple times. Okay, awesome. All right, so yeah, so we weren't able to take it down, but we were able to see that it was sending the right types of packets, right? And all the different, we ran that 3 different ways, 3 different techniques to attack the, to do a DOS attack, right? And those are all labs, these 3 labs here. And it seems like all of those labs could probably be done on a regular Raspberry Pi without anything special. I know I ran the Bluetooth one earlier without any problems. The port scanning and the packet crafting could probably be run on a regular Raspberry Pi as well, and not have to use the as long as you have the the resources, the Wireshark and the Nmap and the HPing 3 installed on either in like a Kali Linux box like this, a virtual machine, or if it's on your regular computer, right? Those are utilities that you can put on your regular computer and run them from there as well. So cool. We have about a half hour left. I don't know what we can get done in a half hour. We can get something started in a half hour if you'd like. Kind of to the point where I'd like to take a break for a couple minutes. If we're going to continue on, I'll take a break. Otherwise, we can be done for the day. I'll leave that kind of up to you. And then tomorrow we'll just start fresh again. And crush out some more of these labs and learn some more ways to use the Raspberry Pi in this type of environment. And crickets.
I'm okay if you stop.
Yeah, this Wednesday with 3 days already. My brains are starting to explode. We got lots of good resources out there today. We did lots of fun things today. So we've actually completed 4. We completed the Bitwarden lab and did 3 other labs. So we did 4 solid labs today. So that's really good. So I think, yeah, I agree. I think we should call it at this point. Yeah, so then I'm going to take a look at that CertClean lab for the, cleaning a USB thumb drive. I think that's going to be, I would like to try to integrate that one into the class tomorrow. So for sure, we're going to look at that one tomorrow. There's a couple others that are from the IoT class, and then we have some other web ones that we can look at as well. So, all right. But yeah, so we'll be done a couple minutes early today, just because of the timing of us being finished with the lab itself, and take the extra time to rest and get ready for tomorrow. And we'll come back and do it again.